Okay, here we go for today. Yesterday, we talked about classifying matter. So taking everything that we know to be matter, books, people, desks, elements, compounds, and trying to put those things into different categories. So yesterday we did kind of like the family tree for matter. We had two main branches, and then we took each of those branches and separated them by what they were made of as well. What we're talking about today are separations. So looking at some of the branches of that tree and how you can separate those branches into their components, or how you could take one example of that substance or mixture, whatever it is, and separate it into what it's made of. So here's what we started with yesterday. We're making a connection to what we talked about yesterday. Everything that we know exists falls under the category of matter. Your books, you, your desk, your pencil, the air you breathe, everything is matter. Matter is either a pure substance or a mixture. This is what we started with yesterday, these two main categories. Everything is either a pure substance or a mixture. The new stuff that we're going to talk about today is how you can separate mixtures into the pure substances that they're made of. Mixtures can be separated into pure substances by physical methods. Physical methods, otherwise known as physical changes. We talked about those already this week. After we did those two main categories yesterday, we took each of those two categories and we broke them down even further. And we said that a pure substance could be made of either an element or a compound. It is possible to take a compound and separate it into its elements, but to do that you would have to use chemical methods, because compounds are atoms that are bonded together. So if you want to separate that chemical compound, you have to use a chemical method. So these would be things like chemical changes that would separate compounds into elements. Mixtures are mixed physically, not chemically. A couple things we need to know about mixtures and physical methods of separation. We're going to go through several examples of those methods today, but before we hit the examples, here are some things that we need to understand first. Physically mixed means something that you could stir with a spoon and mix it up. Think like Chex Mix, chicken soup, cake batter. Mixtures are mixed physically, not chemically. So if you wanted to separate a mixture, usually there will be some physical changes that you can use to separate that mixture back into what it's made of, or separate it into its components. All right, so let's talk about some examples of physical separations. This is one that you're going to do in the lab that we're starting tomorrow, and it's filtering. Do you know what that is? Probably. What are some examples of filters you have in your house? Water filter. What else? An air filter. You have one in your furnace. You have to change it every couple months or so usually. Yeah.
Doesn't a vacuum have a filter?
Yes. Like a HEPA filter. It's supposed to take allergens out of the air. Anything else? Air conditioners have filters. Cars have filters. A couple of them. You guys look a little sleepy this morning. Maybe you didn't use your filter first thing to make coffee. Coffees have, when you make coffee, your coffee maker has a filter. Filters work by separating, usually for us it's going to be solid and a liquid. Some of those filter examples you gave me would be solids or particles that come out of the air. So that would be a solid and a gas. But filters for us will generally be used for a solid and a liquid, and the filter has to have holes that are smaller than the solid. Otherwise the filter doesn't work. If the holes are too big, all the stuff you want to separate just runs right through the filter. And as we said, one very common example of that would be when you make a cup of coffee. You have to put the filter in there so that the coffee grounds don't go down into the actual coffee. Another example that you probably all had experience with would be draining the water off of pasta. Many times you'll put that into a strainer or a colander in your kitchen and you'll drain the water off. Sometimes if you have a pot with a lid, the lid actually has holes in it, so you don't have to use a separate piece of equipment, but it's still a filter. The holes let the water out and the pasta stays in. Coffee usually works as a pretty good example for some vocabulary that we need to know. When you do your lab tomorrow and then finish up next week, one of the vocab words that your lab directions will use is the filtrate. The filtrate is the filtered liquid. It's the liquid that comes through the filter or on the other side of the filter. So if you're making coffee, the coffee itself is the filtrate. The liquid that comes through is the filtrate. We also need to realize that the filtrate may still contain dissolved substances or solids that are smaller than the filter holes. The filtrate may contain dissolved substances or solids that are smaller than the filter holes. This is why making coffee works. If the coffee didn't contain any dissolved substances, it wouldn't be coffee. It would just be the water that you poured in the top. The water goes through the coffee grounds and it dissolves some of those flavors and aromas and colors, and it takes them with into the filtrate. That's how we get our coffee. Second method. This is another one you're going to use in your lab tomorrow and next week. It's called decanting, or to decant something. This is a fancy vocab word that means separating a solid and a liquid, or possibly two liquids that don't mix, simply by pouring off the top layer. You've done this already. You just didn't know that it had a fancy name. If you think back to the lab from last week with all of the different stations, Station 2, when you were up here in the hood, you had a small piece of metal and then you put some acid in on top of it. And when you were done with 2 of the 3 test tubes, you had to pour the acid off the top and then shake the metal into the trash. That's decanting. You separated a solid and a liquid by pouring off the liquid. You can also do that with 2 liquids that don't mix if you pour off the top layer slowly and carefully. If you go take chemistry at college, you might see a piece of equipment that they call a sep funnel or a separation funnel. It's kind of pear-shaped, and then it's got a little spout at the bottom. So sort of like a funnel with a lid. And if you want to separate 2 liquids that don't mix, you can pour them into the funnel, and the funnel's got a valve at the bottom. So then you can drain the bottom liquid off first, and then you just shut the valve as soon as you see the top liquid right at the opening there. So you can separate a solid and a liquid, or 2 liquids that don't mix, by pouring off the top layer. A really simple example would be if you had a beaker of sand and water. If you let it settle, where's the sand going to go? To the bottom. And then you could pour off the water pretty successfully without losing the sand. Another example, this would be 2 liquids that don't mix, would be oil and water. You could potentially pour one liquid off of the other. Which one would be on the top, by the way? The oil, because it's less dense, that'd be on the top. So you could pour off the oil if you were careful and you poured very slowly. One thing it's important to know about this method is that it's based on density. Of course, it's based on which substance or which mixture is on top of the other. Like you said, the oil would be on top of the water. But it's also based on solubility. Solubility means what things dissolve with each other. So if you think about the sand and the water example, does sand dissolve in water? No. So you can use this method. Does salt dissolve in water? Yeah. Would this work for a saltwater mixture?
No.
No, because if it dissolves, you can't separate the two things by pouring one off the other. So it's based on solubility, which means what things will dissolve in each other, as well as density, which tells you which part is going to be on top and which part's going to be on the bottom. Next one, evaporation would separate a dissolved solid from a liquid. If you evaporate the liquid, the solid will be left behind. This would, in fact, work for a mixture of salt water. And this is one of the ways that they make salt. Take a whole bunch of seawater, let the water evaporate, salt gets left behind. In fact, if you've ever been swimming in the ocean, you might have noticed this. You go swimming in the ocean, you get out and you lay on the beach for a while and all the water dries off. Anybody notice that you get kind of crusty white stuff on your skin? That white stuff that's left on your skin would be the salt that's left behind after the water evaporated while you sat in the sun. Okay, we do have a few methods that are, I think, not printed on your notes packet. So, these methods, I believe there are 3 of them. You could jot down at the bottom, or up sides, or if you can find a little other blank space in your packet, you could use that. Probably some blank space on the cover if you get desperate. We don't have a ton more to write down, but we do have a couple other methods to go through. I think there's 3. One other physical separation method would be to separate something by the property of magnetism, or something that's magnetic and something that's not. I actually don't have anything else written on this page because, do you need a definition of magnetism? I hope not. Yeah, it's a magnet. What are some things that are magnetic? Things that are magnetic generally have a metal in them. Some metals are magnetic, some are not. Aluminum, for example, is not. But if you have a substance that is magnetic and a substance that is not, you can separate them with a magnet. And this mixture here, I'll turn on the light so you can see a little better. This is a mixture of sulfur and iron filings. And just by taking a magnet on the end of a stick and pulling it out, here's all the iron filings on the magnet. And if I did this repeatedly, I could separate eventually all of the iron from this mixture from all of the sulfur that's in there. Although it does kind of make a mess. Next one is chromatography. Chromatography is separation by color. Chromatography is often used to separate inks or pigments. So, for example, if any of you watch CSI, Law and Order, those detective kind of shows, and somebody always has to get murdered in those shows, right? 'Cause otherwise they wouldn't have to have a show, or they wouldn't have a show. So the guy gets murdered, and they find the body, and of course, he's got lipstick on his collar. And then they're trying to figure out who kissed him right before he got murdered. You've all seen shows like this, right? Yeah. One of the things that they could actually do in real life is to take a sample of that lipstick and separate it into its components by chromatography. So you can separate that pigment into all of the different pieces or components that make it up. And as you separate it, it would leave a streak of color on a piece of paper, kind of like this. And then if you got a whole bunch of lipstick samples from the drugstore, you separate those two, and you can match the color streaks to figure out which one it was. So hopefully that helps you narrow down your suspect and who was kissing the guy before he got murdered and so forth. But it's actually kind of cool looking when you do it. Here's a little example. I did this with watercolor markers this morning. This is just a piece of filter paper. And I dissolved it with water. So I let water go through that. What would be the vocab word for something that's doing the dissolving? It's from yesterday. Should I give you some choices? Solvent or solute? Which one? Which one does the dissolving? Solvent does the dissolving. Water is called the universal solvent because it dissolves most things very well. So I can do chromatography, separation by color, with watercolor markers using water as my solvent, and we can look and see what streaks of color get left behind. Would this work with a Sharpie?
No.
What would I need to change?
Favorite.
The solvent. I would have to change what I was trying to dissolve the ink with. So I might have to use something like rubbing alcohol or fingernail polish remover. But all we do for chromatography is put a sample of your ink on a little piece of paper, let the solvent run through the paper, and it separates the ink into whatever colors it's made of. This particular one started as blue, black, and yellow. There's a lot more colors than that on it now, which is pretty cool. Okay, last one. Centrifuging is separation by spinning. There are two examples of this up there. Can you tell what they are from the pictures? A washing machine. It separates the water from your clothes by spinning, the spin cycle. What's the other one? Blood. It can separate the red part from the white part, so that's how they separate plasma. Plasma is the white part. By putting it